Hey everybody, happy Thursday, hope you're doing alright. Got a couple things to take care of today, take a look at. Alrighty, so we gotta talk more about exceptions and get through all the exception content here in chapter 16. We did a little bit with some file I/O stuff and catching those exceptions before. Yeah, I had lots of folks ended up having some last minute questions on project number 1. So I did push that one out to 222, and I can do a quick class on 222 where we go over the solution to that. I don't think it'll take up too much of the time I had in mind for the midterm. It won't be too bad, and then we'll look at the midterm as well. Or did we do that yesterday? Not even yesterday, Tuesday. I'm so out of it, folks. I'm sorry. I still haven't quite kicked the cold. Yeah, the practice. So it's not going to be too bad. Oh, Mikey, I'm sorry. You got up at 7 to work on it. Yeah, I did the announcement in an email. I don't know if there's a better way to let you folks know about stuff. I don't know, maybe not everyone checks their email. That student email is probably not the most. You probably don't have that one on your phone. Oh, you never refreshed? I'm sorry. Yeah, so we'll put that one out till Tuesday. We'll take some time Tuesday to talk about it. Probably won't be too bad. Maybe an hour or so. Oh, sorry. And I've not been able to kick this cold. This has been no fun. So I don't know what's going on. yeah, but we'll talk about exceptions today, and then we do need a lab for exceptions. So I was going to have that due in a week. It won't be too bad. That's kind of the idea. So, and hopefully you can even finish it up today. So it'll be relatively quick. So we start the new project here. And let's go 2151, 2. And let's look at custom exceptions. This one's kind of fun. So there's a couple things when it comes to exceptions that you might have noticed. So when we were doing our file I/O stuff, remember, it wouldn't even let us do anything until we had a try block. Right? It totally blocked us out from getting anything done until we added the try catch. But other times, like when we just do something with the keyboard scanner, here, you make a scanner called keyboard, new scanner, and system in, and then we say something like, please enter a number, and then we go get that number, and we have to parse it, right? We say integer.parseInt, given the keyboard.next line. But we've done this a lot. Add our import for scanner. Maybe we'll add the import for scanner. I think I spelled it right. There it goes. Just had to wake up a little bit. There. All right. And when we run this one, you'll notice this can cause an exception, but it doesn't make us do a try and a catch block. Right, and if we enter 10 in words, letters, we get a number format exception. We get an exception happening and we crash, but we weren't required to put it inside of a try catch block. Now we could, right? We could say, hey, I want to try this thing, and then I want to catch a number format exception. And then we can just print out that exception or something, sure. Now, exception actually has a couple interesting attributes here. You can get the message, you can get the entire stack trace, either one here, which is kind of nice. Or you can like call print stack trace, which is just a void method. So if you call print stack trace, it's going to go print it. Notice it had an overload there when we looked at print stack trace. You give it a print stream or a print writer where you can put that stack trace. So you could print it to a specific output if you wanted. And now let's give this one a run. And again, if we type in 10 in letters, oh, it's not. Pretty sure, maybe that's the same one. Yeah, have a good day. I don't think it was supposed to be red. I think it's that compile is getting. I want to check real quick. 10. Oh no, okay. So we do it prints it, and then we kind of get this mixed input output thing here. So it's a little bit funky with the print. Generally, right, I just call print on the exception itself, and it will toString itself, and then you get a nice little exception message. This one's a little bit nicer. But if you want the whole stack trace, right, it doesn't give you that where it was caused. So getting the whole stack trace is pretty handy. You can get the stack trace. Oh goodness, nope, I didn't even print it right. Sorry, because that's an array. Ugh. Okay, so that's ugly too. So probably just printing it's probably easiest. But again, the idea here is that this was an optional try catch. Now it was a good idea for sure. Definitely recommended, but not required. But when we do something with the file input and output, Right? If I would say, hey, file equals a new file, test.txt, and then if we want to, let's get one of those. And if we want to read from it here, let me go grab that code because I don't even remember. Ah, here it is. That's right. Let's look at our code here. Yeah, so we'll grab a object output stream and go right to it here. And actually, let's do a not an object output stream. We just want a regular. Okay, I grabbed the wrong one. I don't want to do binary. It's fine. It's fine. We can do one or the other. And I'll just make this a io.star import. Now we get the red line saying unreported exception, IO exception, must be caught or declared to be thrown. Well, what's the difference? Right? This one could cause an exception, but we don't have to try and catch it, but this one does. And it turns out in this, the way that Java has done all of its exceptions, there are essentially two different types. There are unchecked exceptions, and there are checked exceptions. If you're a checked exception, you have to be handled before the code will compile. If it's unchecked, well, it's up to you if you want to catch it or not. So the kind of IO exception, if we just go Google here, with Java IO exception, you can actually see in the Java API. This Java API is actually really cool. Right, it's coming from our exception type here. Right, it is a type of exception. Right, where do we see that is checked? I don't see that there. That's okay. Let's look up another one here. So that's the first one. And let's set up Java API for the format exception. Not type anything. Java API format exception. So this one here inherits from a runtime exception. Being a runtime exception means it could crash at runtime, and we don't need to be going and catching it. You don't have to. Not required, but you can. Versus the IO exceptions are not. Hector, thank you so much for donating those bits to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. Whew. No, that's so cool. And actually, I just got a payout from Twitch. I was super excited. So they sent me a check, not even a check, it's an electronic check, but a deposit. So we're up to now $250 worth of donations to the Student Scholarship Fund just because I've been doing my classes here on Twitch, which is super fantastic from all the support from you folks. So that's really cool. And Zoom sucks, so. No, but I've enjoyed Twitch, and I think it's been a lot of fun. It's a different format for sure. And I'll always happy to hop on voice chat with you folks if you want, because I think that's really the only thing we're missing is a chance for you to like pop in over voice and ask questions. But let me know. Always open to that, or meeting afterwards. The lab style format, doing screen shares. Zoom's fine for that, or Discord's fine for that. But I don't know. I have one class that meets on Zoom, and it's silly. And then it takes me like an hour to convert the recording to something I can upload to YouTube, and I have to upload it to YouTube, and it's a bunch of extra steps. But that's okay. Okay, so anyways, you'll notice this is a runtime exception inherits from in this chain here, where this one's not. So the runtime exceptions don't need to be caught. So inherits from runtime exception, and as it might sound, right, it's an exception that happens at runtime. We don't know if it's going to cause an exception until the program runs. But this one here, we know it could happen, right, because we're checking for it here, and we have to handle these. So these are checked exceptions. Must be try catch. Or you could do the bad thing here, and you probably did this bad thing in 1500 because we just didn't have a lot of time to talk about exceptions. And the other option you have here, it must be caught or declared to be thrown. Right, this declared to be thrown. Declared to be thrown means thrown. It means you're just going to tell Java, yeah, I know a bad thing can happen, and I don't care. I'm going to let it happen, which is, you know, it happens. So it's not the worst thing in the world, but definitely better to try and catch and handle those exceptions yourself. So this declared to be thrown means you tell Java the method here throws, you can say throws IO exception. We're telling Java, hey, by the way, my method might throw an exception. I know it might throw an exception, and I don't care. Right? We're just going to let it crash. So this was the lazy approach you probably did in 1500. And again, it's okay. We just don't really have a lot of time to cover everything. I don't think the try-catch blocks are too hard, but sure, it's okay. One way or the other. So if you did, great. If you didn't, that's okay too. So I'm not a fan of this here. But we're going to see that this sort of declaration can actually be really useful when we're making our own, oh my goodness, our own exceptions. So these are all the built-in exceptions here. So what we can do is we can write our own class here. Let's make a new class here in our package. We'll call this the item class. I'm a fan of selling things. Why not? Pretending to sell things. So then item will have a private double for cost or price maybe. It'll have a string for name. And how about a private int for quantity on hand? Okay, and then again, we'll just let Java write the rest of the code, or we'll let NetBeans write the rest of the code for us. We'll do a constructor that takes all those attributes, and then we'll add some sets and gets. Now, for price, we want to do some sanity checking here, right? We want to make sure that if my price is less than 0, I don't want to do anything, right? I want to do something else. Now, before what we had done is we would just kind of like return a Boolean value or something, or just set it to 0, and that wasn't really great here, right? So what I want to do is I want to throw an invalid, is it an argument? Oh goodness, where is it here? Hang on. It is illegal argument exception is a very common one. Illegal argument exception. Nope. Argument exception. I can't. There we go. And if you throw a new illegal argument exception, you can give it price not be negative. You can give it a string here inside of this, and this becomes the message, which is really cool. And now, again, you don't want to just accept price here. This is the Java API site, so docs.oracle.com/Java. And I think actually we probably want version 8 at this point, but just when you Google, it's pretty much the same. So version 8 is their official latest Java release. The OpenJDK maps to the 8 essentially here. It's that weird split of things. They just Google Java API, so this will define all the things about Java. So you can find all things Java library. So anything in the Java IO library, let's go see what's in Java IO. And you can see all the fun things in Java IO. And you can read about object output streams. And it will tell you all the things about object output streams. We'll give you some example code. We'll tell you about throws exceptions, these sorts of things. So it's pretty handy. It gives you examples for each of the, here's a constructor that you can use. It's a lot of information, definitely super handy. It's a little overwhelming sometimes maybe, So we don't, I don't know, I don't generally tend to show this to people in 1500, just because there's so much there. Ooh, and frames are fun too. This way you can get this little, like, these are all the classes in the Java library. These are all the packages in the Java library. You can look at all the packages, or you can look at classes here by name, and you can look up anything that you want in here. Anything that is in the Java API. So it's really handy. But just like this is kind of an overwhelming list of like, hey, here's all the things Java can do for you. Oh. So, no, but it is pretty handy. So again, if we are doing our sanity checking here on price, we don't want to just accept the price here. We want to use our method that does all that sanity checking. So we'll just call set price here, right? Do that sort of thing. Now I'm going to comment this stuff out because I don't really care if it's there right now. But what I want to have is a new item. So item equals a new item. And we have to give item, well, we said coffee, we have to give it a quantity and a price, right? Item wants the name, the price, and the quantity on hand. So if we give it a negative price here, Java's not going to care. Joey. Oh my goodness, friend. So if we give it a negative price, we know an exception could happen, but it doesn't care right now if that's going to happen, right? And when we run it, now it's going to crash. Enter our number. Again, we can handle that one, but now we get illegal argument exception on set price, and it's crashing here. But we'll see our message a little more to the right here. Here. Oops, too far. Price cannot be negative. So we gave it a message here that shows up. So most of the time, it's pretty easy to just use your own exceptions here, right? Or use a built-in, to use a built-in exception type. But if you want, you can make custom ones. Or the other thing we can do is we can tell Java now, hey, this method throws an illegal argument exception here. So we can indicate that, hey, we're going to throw an exception, which is kind of fun. Oh, that's right. It was telling me it's fine. Did I turn off that compile and save option? I don't remember if I did or not. 10, we get our exception. One more time. Right, so we can see it's just totally failing here. So it's up to us then to have to deal with that and catch it. Oh my goodness, what is it doing here? There it goes. And we still get our illegal argument. So we can do our own try-catch here with item, right? Or we can give it a good price here, and then I can call item.setPrice. And then, nope, set price. Price, there we go. I don't know why it always does that other set. That's so annoying. -1. Right? So declaring it doesn't gain us a whole lot here. It's not very interesting. But we can, you can mark if you want. So some of the stuff in the API, it's good to mark. It's a good practice to do it. I guess I'll leave it in here. Wait, why? Helps mark your code up, which is nice that it can happen, but it's okay. But we could do a try catch if we wanted here, right? But we could try and catch our own. Was it an illegal argument? Yeah, legal argument exception. And we can print out the exception. Right, and this time now, we're going to get that prettier looking message, and the program will continue on. Da, 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 da. Do a regular number, and we get price cannot be negative. Right, you just get the nice message here. Now, it's possible that more than one exception type could happen, and we've seen, so when we were doing that file input and output stuff, we had to have multiple catches. Right, we did a catch, here's the IO exception, a catch a class not found exception when we were doing our casting here. So you can have multiple catch blocks, right, of specific types. So when you catch exceptions, right, because they all inherit from exception, this is like the last ditch effort to catch. You want to try and be specific first and then have a more general one afterwards, if you want to handle them in a specific order. Because I could have another block here for catch exception and do this, but this one will never run because it's going to be caught as the type of illegal argument exception first. So our exception here is going to catch it because it matches this type. If we don't use this type, it would catch it here. Right? Or I could have, if we wanted to be silly, you could have another catch for, we'll say like IO exception, EX. I think it's, is it even going to tell me? Oh, okay. Just X out. The exception, yeah, it even knows here the IO exception is never thrown in the body of the corresponding statement. So it's smart enough to know, hey, that one's never even going to happen ever. But it knows an illegal argument exception could happen here. Let me grab some more coffee. But the next thing we could do if we wanted to use our own exceptions. So I can write a class that extends exception, or any one of those exception types I want. So I'm going to have a how about a negative argument exception? And we want to say we extends, how about the illegal argument exception? Now, this is technically all we need here. We can use this now, but without adding the constructor that accepts a message, like this one here, we can't really pass that message up to our superclass. So this is enough, but it's better to add a constructor here. So we're going to insert code, insert a constructor, and it is even showing me, hey, which of these do you want to do here? Right? Which superclass constructor do we want to call? So let's do the first two. Because I mean, we can do them all, I guess. Why not? We'll add all of them here. And we'll just call our superclass given the string or the message, whatever here, right? I think that should be message. That shouldn't be S. Silly as S. So it'll generate those for us. So we have a matching no argument constructor. Right, our no argument constructor will implicitly call the superclass constructor. That's the no argument constructor here. Right? So this happens implicitly. Implicitly. I think that's how you spell it. You don't need to do that. There's nothing wrong with adding it, but it's going to happen automatically with the no argument constructor. But now we can have the message and these sorts of things here. So in my item class, then, I can, instead of throwing an illegal argument exception, I can throw a negative argument exception. And I can give it a message, price cannot be negative. And now in here, I can catch either the parent class type, its exception is a parent of the parent of the parent, sure, or I can catch that very specific negative argument exception. Right? We can run this. We can use our own exception type here on this one. Right? And we see, okay, a negative argument exception, price cannot be negative. So we see, hey, this is the specific type here. I'm not super fond of making my own exception types, as I feel like there's enough in the Java API. But if you'd like to make a custom one here, you are more than welcome to do it, which is fun. So you can add in, and you can add other properties and stuff about it as well. It's your own class, right? But because it extends it, you can use the throws and everything like that, which is fun. So again, we'll do this for the lab, but I'm not going to ask you to do it for any other sort of projects. I think you're fine just using like an illegal argument exception or something similar, something similar to that. Okay, but now we would also probably want to do the same thing with our quantity on hand, right? You can't have negative of these things on hand, right? quantity on hand cannot be negative. And really, if you're going to throw, the code stops. So the else part here is kind of redundant. It doesn't actually need to be in an else block, because if you throw, the code stops running here. And we'll do the same thing. We'll call our set quantity on hand. So we can get that checking here, right, in our, hey, did you give me valid values here? Okay. Am I feeling okay so far? Dealing with exceptions? Let me grab this and make sure I'm not missing too much here. Oh, excuse me. Oh. All right, almost there, sorry. Yeah, my coffee is not hot enough. I've been sitting in the mug here too long. It's really unfortunate. All right, there we go. Found what I was looking for. Exceptions. Custom exceptions. Runtime exceptions versus regular exceptions. Okay, cool. Yeah, I think that's pretty good. Oh, there is the finally block we haven't talked about. We can do the finally block. I think that's about all we need there. Yeah, I think that's good. Oh, and in an interface, you can define that a method will throw an exception. Like we said, hey, this one throws, this is actually negative argument exception, right? You can declare a method to throw an exception in an interface, which is kind of fun too. So as you're writing an interface, like, hey, this might throw some sort of exception here. That's all. Okay. And then in our catch box here we go. So let's put this one back in. Oops. No. Oh, I had too many lines this way. This one. There we go. So let's do, instead of an object output stream, we want to do our data output stream. Object output stream, data output stream. We'll call this one our test.txt, so we don't need this file object here, right? Oh, okay, I just had too many parentheses. So we're going to, instead of doing this one up here, right, we want to do our try block. We're going to put this all in a try. And then we can catch an IO exception and print out, whatever bad thing happened here. But then I want to add a finally. So a finally block lets me say, okay, regardless of if this try finished or the catch ran, what are we going to do here? Is what the finally block lets me do. So I can add some sort of handling here to deal with, oh, well, what if something bad happened? What do I want to do at the end here? And a lot of times what we want to do in our finally blocks is we want to kind of close our file IO to finish everything that's been happening here. So we'll actually use, before this starts, we'll declare our binary output file as a type here. We'll just start it off as null. Outside of that, and then finally I can call binary output file dot close, and try and deal with that if it's not null. So if my binary output file is not null, so if it did get created here, then we'll try and go and close this thing here. Oops, close it. Now this could also cause an exception, which is pretty silly here, but we then put this in another try block, catch an IO exception, and this was just a, we couldn't close the file or something. That's probably less common, that it will fail to close here. But if something fails when we're writing in it, our binary output file dot write, all right, let's just, we'll write UTF. Happy Thursday. So we can write something to it, and then instead of closing it here, we'll do it in the finally block. We'll just let it close down here. This just makes sure that if an exception does happen, you're gonna try one last time to close it, because if you leave files open, weird things can happen if you try and then go open them or write to them later. So you want to always make sure they're getting closed. So this is like one last check to do that with it here. It's not, I mean, for our programs, we're doing things and opening and closing and just ending. We weren't really a long-running program that would open it, read write to it, and then close it, but the program would keep running. So if our program was like constantly running with some sort of menu, hey, what do you want to do, and not ending, then we want to make sure that they get closed properly like this. Again, we're probably not going to get many of these exceptions, but sometimes weird IO stuff can happen, because part of input and output is really beyond Java's control. Java will ask the operating system to do something, and it usually will work, right? But if something super weird happens on the computer, and the operating system says, oh, nope, something bad happened, you can't write to that file, you can't read from that file, we should handle that gracefully. So that's why we always have these try and catch ones in here. And then there's one last, you can automatically close. So this is kind of obnoxious to have to do it this way. So the easier thing to do then is you can put these sorts of things inside of the try, because this is a super common, hey, I just want to close it when I'm done here thing. So we can say, hey, I want to try, let's do a buffered reader. We'll call it input equals a new buffered reader given a new file reader given like test.txt. Now this looks really ugly here. This is long. So we're going to start a try block, and then we're going to catch that IO exception. And again, we'll just print out the exception. But by putting it inside the try block, this is a will automatically close the input. Right, and then here, then we can say, we can output whatever we get, input.readline or something. So it's automatically going to close it here. So this is really handy to avoid having to do this finally block, right? Because we're putting it in here, it's automatically going to close it when we're done, regardless. So this is definitely a much easier syntax. It just looks kind of funny here, like we're putting all of that reader stuff inside of here, but should be okay. Does that part make sense? Oh, excuse me. cool. So you folks are doing great. I think that's pretty good for exceptions here. So we will have one last quiz on exceptions before the midterm, and those questions can be fair game on the midterm. So let me post that one for you folks. And we'll talk about the lab assignments too. Let's do that. Let me move this one over. Back to assignments, we'll do a new lab. We'll pull up the GitHub Classroom thing. Excuse me. So are you folks familiar with the quadratic equation? X equals negative b plus or minus the square root of b squared minus 4ac, both divided by 2a. I'm sure you wanted to come back to math class. But that's a fun one, the little quadratic equation here. This is CIS 2151, winter 2022. This is lab 7 here then. We'll pull up our Java template. Okay, and we'll do that feedback pull request. Here we go. All right, so new lab 7 for exceptions. That's your favorite equation? All right. Actually, I learned it as a song back in middle school that I didn't actually know was, I don't know, I'm terrible with things like that, but that was fine. 10 points for this one here. So apparently it was some school's fight song. I don't know. And I'm terrible at singing, so I won't subject you to that. Submit the feedback pull request URL. So we're going to write a little helper program that will help calculate the roots. Write a helper program that calculates, or the x-intercepts for a quadratic formula. Quadratic, can't spell this right. Quadratic formula. Still quadratic? No, I thought there was a T in there. Quadratic formula. Yeah, that's the thing, right? We just not have the. It's just doesn't think it's a word. Sure. So remember that is, we have y equals, we have a x squared plus bx plus c is the formula here. So we're going to ask the user to enter values for a, b, and c. Then calculate the roots if, the intercepts if possible. Add a custom exception for no intercepts, no x-intercepts. You throw if the determinant is negative. Determinant. There we go. So the determinant here is this portion of the formula. It is the square root of b squared minus 4ac. Right? If b squared minus 4ac is negative, determinant is, right? You can't take the square root of a negative number. Right? If this is negative, right, throw that exception. So we're going to write the function, write the method that does this, and throw that as an exception if that's negative. Okay? Otherwise, we're going to have x equals negative b plus or minus the square root of b squared minus 4ac, and then the whole thing is divided by 2a, right? That's both sides here. So either do it after, right, or beforehand. You can divide the square root side by 2a and then the negative b side by 2a if you want, or do the arithmetic, and then divide by 2a, right? Pretty sure. I wish Mr. Tim was here. He would definitely check me on this. He's our fantastic CIS tutor who got a math degree. So then we're going to give them both, right? This plus or minus means there's going to be two different results here. So what we need to do is we need to set in the class, set the, I don't know, we'll say first x-intercept to the plus value and a second x-intercept to a minus value, right? So we want to write it. We're going to write a class for this. Class quadratic solver that has a constructor that accepts values for a, b, and c. Right? Then calculate the intercepts if possible. So inside the constructor, we're going to try and set it here. We're going to add this no x-intercepts if the determinant is negative. Now, it's okay if these are the same. They're possible there's only one intercept, and first and second will be the same, and that's okay. We'll want to have a no x-intercepts. So when you create this quadratic solver, an instance of quadratic solver, if this determinant is negative, throw this exception. Otherwise, here's your formula for the first x-intercept and the second x-intercept, right? One is plus, one is minus. Right, okay, let's just say this. So first x-intercept is equal to plus, and then the second x-intercept is equal to the minus. How about that? Does that make that a little easier here? Oops, too far. So negative b minus the square root of b squared minus 4ac both divided by 2a. Right? And then we're going to include get methods for both x-intercepts attributes. That part makes sense? Let's also have include get methods for a, b, and c as well. So like accept values for a, b, and c, sure, and we'll have the get methods for those too. And let's for fun include a toString method that outputs a pretty ax squared plus bx plus c string. How about that? And we'll do both and the x-intercepts. Okay. So again, we should be able to get this done in the hour before class is over. Not anything too crazy here, but we'll write a class. We'll have it possibly throw an exception if the determinant's negative, given an a, b, and c value. And then we'll set first x-intercept, second x-intercept. We'll add the get methods for all of them, and then the override the toString, include a overrided toString method. There we go. Overrided. Did I spell overrided wrong? Overrided? Is there overridden? Sure. Overridden toString method? I don't know. Likes that one. That makes sense? What we're going for? All right. Awesome. Let's get to work on. Any other questions about the project? I know I answered as many of them I could individually last night. Some people had questions about tools, about spaces, that sort of thing. Anything on your mind, or did I get them all answered last night? I just didn't want folks staying up all night or getting up at 7. Sorry, Mikey, to try and get that in last minute. There's not really the big rush on it, so I still plan to have the midterm open Tuesday, but I'll stream. I'll do a regular lecture here solving that project if you're interested in watching that, either live or then you can just watch the recording after the fact if you'd rather do that. So we'll still have all next week. The midterm will still open on whatever that day is, 5 days from now, the 22nd. Yeah, midterm will open on the 22nd. So if you want to wait until the exceptions quizzes is done and you can see your answers there, that's great. Or maybe I'll just open that one up. I can open the answers early. So the player should move around the island. Like, you should give them the option of go up, go down, go left, go right. So not just going through every single space, but like if you're at this space, if you're at like 2-2, say, do you want to go up? And then it'll go up to 1-2, or do you want to go down? You'll go down to 3-2, or you want to go left? You'll go to 2-1, or go right will be 2-3. Yeah, so some sort of loop, like what do you want to do? And then we'll say, okay, this is what's on the space. And then if there's a tool there, we'll get the description of the space. Say if there's any tools, you can pick up these tools, give them an option to pick up, or add the tool to their backpack. That was kind of the idea. Like they'd have a collection of these tools, and tool can be flexible. Right? If it's a class tool, we can make it be really anything, any sort of name we want. But we know what shovels and axes and I forget. Whatever we're going to be for building, for cutting, for chopping and digging. Hammer, right? Was it hammer for building? I think it was hammer for building. Again, if you want to take that in any direction, that's fine. So Rochelle, the space class itself should probably have an attribute for the tool. I think I've got that in here. So then you can, like, when you land on a space, you can like say, hey, is there a tool here? It might have an option for get tool or set tool. So you can see if there's a tool there, then you can get the name of the tool after you call get tool. Let's see, do I have that one? I think I've got that one open. Let's see. I don't write too much of it here, but kind of give you that little shell of it here. Might be useful. Yeah, so this has the random chance of having a tool. So like when we're creating a space, you might pick a random number, a 1 through 10, maybe 1's a hammer, 2's a something, 3's a something else, and then otherwise it doesn't have one, and that's okay. So you can use nulls. You got to be a little careful with nulls here, but you can use null, meaning it doesn't exist. There is no tool here. So anytime you're dealing with those objects, or null is a possibility, you just need to be careful. Come on, NetBeans, you're killing me here. I'm getting close to switching over, but unfortunately it's not going to happen this semester because I have to get IT to install the software for us. But we'll be able to use IntelliJ, I think, moving forward, and that'll be a lot nicer. Yeah, a separate. If you just use names or strings, it's probably okay. I think a different class is going to be a little easier for you, for sure. Oops, I didn't click the right project. That's why I was like, come on, open it. And I was just sitting here waiting for it. That was silly. So we had like this space here. So if we had a new class for tool, again, tool, we get some sort of properties and whatnot here, but space could have a private tool, and it may or may not have something here, right? We can add the gets and sets for it. And if it's null, we can give them back null. So we have to check for that. We say, hey, if space.getTool is null, then there is no tool. Don't worry about it. But if it's not null, then I can go get that description of the tool. Right? So then in the space constructor, we can say, hey, if math.random times 5, I don't know, or something, as an integer, goodness, as an integer equals a 2 or something, right? Maybe we'll say tool equals a new tool, and this one's like a hammer or something like that. I don't know. And tool it's something here, right? Sure. Name, string name, and then like add a constructor for it or something. And not finished. This is just kind of scaffolding for you here, but like something like this, you might have an option. And again, this is don't put this inside of an if. You have to set this as a value first. So I want to not write everything for you here. Yep. So you can have the tool there, and then you can have methods for get tool, like as you're moving around the space, right? We were going to have that like the player class, not a folder, like a player class, and player would have an island. Right, private island, and then something player could do, I don't know, as we move around, like the player would know where they are, get the current space that they're on, because player probably knows where they are, and then somewhere in the game loop, my goodness here, right? We had these, again, spaces, you could do sort of things in, you could get your location out of the island, but we could get their current location and then see what's in it here. So how about player then might have a public space, get current space or something. I don't know, and then would have to give us back their current space from the island and all that fun stuff. So like island would have its spaces, and you could get a space out of the island. So like it's a big chain of calls here, but generally it works out pretty well. So maybe this one has a method public space get space given an int row and an int column or something. We'll return spaces.get row .get column. Something like that. Yep. So then player might have that list of tools, right? They might have an array list of type tools. Right. So then if the player has their list of tools, we need a way to add a tool. So public void like add tool, given a tool, we can say tools.add the tool. Right, to add a tool. Hey Moose, how you doing today? Good to see you, my friend. And if you folks are looking for some wholesome content, just a fun place to hang out, definitely go check out our friend Moose here. It's fantastic. What were you streaming last? Oh, my shout-out's not smart enough to do that, Moose. I gotta get better bots, better bot commands or something. Right, so the player probably knows where they are too, like an int current row and an int for current column. Column. Does column have two L's? One L? Two L's? Column? No, that looks wrong. I'm just going to go with call because I don't actually know. So we'll return our island dot get current space, right, of the current row and current column. It'll tell you what space I'm on, right? So then you could do that sort of thing. Oh, no problem, Moose. No problem. It's super boring here to like be super focused on Java for 2 hours at a time. So we gotta have some distractions. That's what all the dad jokes are for and stuff. Like the class will call the class that calls the class that calls the class, and eventually here, right? If our player has a game here, or if our game has a player here, player equals a new player, right? We can get the space that they're on, so we can have a space current space is my player.get current space. Right, and then I can get the tool, right? The tool for tool equals the current space dot get tool. Oops, well, we don't have that yet. We had to add that, right? A get for tool. Insert code, a getter for tool. Right, but then this is just getting the tool. You probably also need a way to pick up the tool, which will then take it out and go set it back to null, that sort of thing. That gets tool. We get the tool, and then we can check, hey, if tool does not equal null, I don't know, you found a tool.getName or something. I don't know. Or, yeah, add in a toString, and any sort of things you want to do here. This is very incomplete, just trying to sketch out some ideas here of how some of these things might relate, right? So player has the island has the spaces have the tool. So like it's a big old chain of getting all these things out here. Crow, don't even usually use Java in real life. You know, Java is still wildly popular, which is really cool. There's this Stack Overflow developer survey. So this is like a survey all of Stack Overflow. Not everybody. It's a decent subset of programmers here. And we want to read the overview. We want, let's see. What are we looking for? Languages or something, right? One of these things was like top languages, developer experience, code, years of coding experience, professionally. Something there's in here about languages, right? This is years of experience by type, developer roles, education, age. I thought there was a thing about language. Oh, popular technologies. I think that's what it was. Yeah, here we go. So this is of all respondents or just people who list themselves as professional developers here. Um, like web stuff, huge for sure. Tons of things are going web. SQL, working with the database, definitely huge because like anything now is database backed. Python TypeScript is a wrapper for JavaScript. Node is another JavaScript tool, and then Java. So Python beats out Java as a commonly used language here. But Java here is huge, wildly popular. C++ is still very, very popular. Lots of applications will use it, and depending on your industry, maybe lots of things, especially like embedded systems, are going to be a lower level, like a C++ style language, where you don't have the ability to run that virtual machine, Java virtual machine or something in a runtime environment. Oh yeah, I mean, understanding coding is huge, Mikey, and that's why, like our intro to coding class is part of more than just the software engineer track. Having just a basic foundation for programming is huge for people to understand that in the IT space. Yeah, so very, very popular still. Lots of web stuff for sure. Database stuff, yeah. Python. I don't actually know like what they do with that. Not like this is just what you use day to day. So I don't know. But yeah, Java is still a very, very popular application language here. And as you go on down, you see all these fun little ones here. And this is people surveyed who identify as a professional developer. Like this is their job here versus all respondents. These are just people who happen to use Stack Overflow. You can kind of flip between the two and see like hobby developers. Maybe they use some of it in their job, but it's not their full time job. Yeah, for years I was a systems analyst, and I would do little programming tasks for automation and solving problems and things that I wanted to do, but it wouldn't say my job was as a developer. So, but yeah, this is really cool. The Stack Overflow survey is really cool. There's also top paying technologies, right, which is fun. So based on programming languages, this one's not quite as fun looking here. Like Java's not as high up on the list, but that's okay. And again, I think this is global. I don't think this is just US. It's not last place. PHP is pretty low down on the list here. But I'm not sure where this like it's from here, because it's 46,000. I don't know if it's just US or what. But like you can just go Google jobs for Java, and then you can like see average salaries and things like that. Like for stuff like that, this is like people will report their own salaries, and mostly anonymously for organizations. So you can look up jobs and salaries here. Do you really want to sign in? I don't want to sign in. That's stupid. I don't want to sign in right now. But like you can search jobs and find salaries and things like that. So you can like look for a Java developer salary sort of thing. So it's really going to depend, Crow. Really going to. I wouldn't put a whole lot of stock into this necessarily. That like, hey, knowing this language will get you that job, because some of this also comes with like that experience and that developer role and that sort of thing. Look at that. Look how pretty this is. My tools here: Visual Studio, Notepad, and Code, IntelliJ. Eclipse is down here. Where's our? We don't even show up on the list, do we? With NetBeans. That's a bummer. So what is this one here? Vim, yeah. Oh, what they want to work in versus what they actually do work in. Where's that? So 46,000 who work with Visual Studio Code want to work in Visual Studio Code, but some people There's the other direction here then, right? Look at add. I want to find the other outbound here. They want to work in Xcode. So I don't know. This is just kind of like a fun little. These little graphs are really interesting. Really pretty graphs. So their Stack Overflow survey is really fun. Where were we? Sorry, about the project. Right? Does this help, like, kind of walking you through all of this? If a player knows where they are on the island knows what space they have, the space knows what tools it's on it, we can do something with it. Right? You want to pick it up. I don't know. To pick it up. That's sort of, do these sorts of things here. Okay, cool. Yeah, so let me know what you've got going on. So we'll cover this on Tuesday. We'll get the midterm starting on Tuesday. So Visual Studio is the full development environment. I really like Visual Studio. It's a little heavier, a little slower, depending on what you're working on too. Visual Studio Code is the stripped down version, mainly as a text editor with some debugging features. It does a lot of stuff, and there's a ton of plugins for it. There's actually a decent amount of community support in Visual Studio Code. So some folks have actually had do Java in Visual Studio Code because they like Visual Studio Code and they're familiar with it, which is fine. It's a little bit trickier to do a few of the things, but it wasn't too bad. So it's a very flexible environment. It's mostly started off as like a really pretty text editor, and then they've added on features to it from there through plugins and things. So maybe not everybody manages the Kubernetes side of things, but they might work with a Docker image. So like there's stuff I can do in a Docker image for doing testing and deployment sort of things, but I don't actually go and touch the Kubernetes side of things. And I think Kubernetes is just one of the possible tools you can use with Docker. I think you have other options for Docker that don't require Kubernetes too, if I recall. It's been a little while. All right, cool. So I think we're good to call it a day then. Let me go commit this stuff to GitHub before I forget. And we'll go from there, okay? I'm gonna grab some more coffee. Oh, is NetBeans out there? Okay. I mean, it does a lot of stuff. It's just it's pretty slow for me and a little bit flaky. But part of that might be my computer, which is sad too, but that's okay. Let's do 2151. So here is, let me do like exceptions first, and then I'll update the project stuff. So I'll say exceptions. You can tell why I always wear a hat now. All right, and then here's project one ideas. Again, just some ideas. There's definitely a couple different ways of going about this, and that's part of the fun here. Right, programming really is an art, not just a science. So different ways of designing it, which is fun. One thing I'd recommend, I'm not going to mark you down for it here, but notice none of these classes here have anything to do with system out print line. Right? Classes generally should not print things. The place where you want to print things is the essentially class here that has the main method. Right? Main knows that it's a console application. It knows it can print things to the console, and you'll go see it. The classes themselves care less where they're being used. Right? So if you wanted to take this and turn it into a mobile game, which is, would need to add a lot more to make it interesting, but we're just starting a little foundation here, playing around with some of these ideas. The classes shouldn't care. Right? If you wanted to turn it into a web application, the classes don't care. Right? If we're going to make a graphical user interface out of this, the classes don't care. Right? So classes should not be printing things. Again, if you went down that route, don't worry about it. You don't need to go change it. But the habit and the practice should be classes just have their information and have methods that you interact with them. You can pass them information through a method, or you can get information out like with get methods, get those attributes back out. It's up to you to decide who's using the classes. If I want to be displaying them on the console, displaying them in the graphical user interface, in a web application, a mobile application, yada, yada, yada. Okay? All right, so it's been fun. Oh, goodness. I must not have hit save on some of these things. That's fine. Saves. Sure. And I don't know what we do with space. That's fine. Oh, yeah, it's a good tool. Okay, cool. All right, folks. You take care. Let me know what I can do. And yeah, GitHub for sure, Pro. They're a pretty handy hosting provider, the Git source control tool. I'm a fan of them. And then different IDEs will have different integrations with Git directly, but the GitHub desktop client itself, the GitHub desktop client, or UI, sorry. I don't actually use the client as often. Most of the time, if I'm working with it, I'm doing it from the command prompt, right? Or Visual Studio has some nice plugins too. This desktop tool, no problem. Yeah, sometimes not too much. A lot of times I'll just do stuff from the command line. Yeah, Shady, there's a lot of different technologies out there for sure, and no one's going to know all of them. So don't feel bad if you don't know them all. All right, folks. Hey, I'll post that survey here. I'll post this one in our Discord because it's really cool. Okay? All right, folks. You take care. Let me know what I can do to help, okay? I'll see you around.